Me, myself, is Noor Asfaruddin, and my roommates are Naveen, Nurani Suraya, Resma, and Sasitaran. Our company background. Our core business is the design and execution of ground investigations and the provision of geotechnical and ground contamination risk assessment reports. Our latest technology and well-trained workforce has made our name well-known in this market field. Wherever we operate, our employees are focused to our mission of being the premier drilling company, provide a good service and quality to our customers. These are our company background details. Briefing of project. The client of this project is Jaffer Enterprise Sdn Bhd. This project is focusing on to study the soil investigation works for slope investigation of 4-story shop office. Sri Sayang Sdn Bhd is being selected in order to be the soil investigator for this project. The project title: Slope Investigation for 40 times 85 square feet of 4-story shop office on lot 0.25 Jelutong, Pulau Pinang for Jaffa Enterprise.
Hello, my name is Naveen Tyagarajan. My matrix number is AF180011, and I'm going to talk about Chapter 2, Bore log analysis. Bore log is the practice of making a detailed record of the geologic formation penetrated by a borehole. The log may be based on visual or inspected of sample brought to the surface or on physical measurements made by instruments lowered into the hole. Some types of geophysical well logs can be done during any phase such as drilling, completing, producing or abandoning. The table below shows the soil profile on a proposed construction site. Besides analysis of bore log, also beneficial to collect some information such as buildability and design of shoring application in order to smoothen the process during the planning phase of construction project. This is the soil profile of the proposed construction site. Next, in addition, the geotechnical engineer is commonly focused on design and site lifespan. Other than that, a detailed bore log is able to provide several key information, included the variety of the soil, either is non-compressive or compressive soil. In other words, we are able to determine the soil based on its type such as clay soil or sand and gravel. The table below shows the cohesive of silt and clay based on SPT. Besides, bore log also provide the information for water table and consistency of soil such as natural moisture content, plastic index, plastic limit and liquid limit of soil. Based on significant information mentioned earlier, it will generate a thought on exploration of the site and the strength and durability of soil to support the shoring system right after the cut. Hence, determining the soil type is important because clays behave majorly different if compared to sand and gravel. The fact is being so that type of soil will bring consequence on each of the shoring decision. Thus, dewatering process of cohesive soils can be achieved from internal sumps of the excavation. Meanwhile, dewatering process of non-cohesive soils may need to dewater from external wells of the excavation. Both of these conditions present a major difference in cost.
This is Darren. Now I'm going to discuss about the calculation part. This is the soil profile which got 3 layers with the unit weight and cohesion. For the group A, the load is 100 kN with the pipe pile dimension with the diameter of 600 mm and the length is 13 meter with the column 1 and column 3. For the QP, we use Mayoff method to calculate which is 48.35 kN. For the QS, firstly we use alpha method which obtain 373.91 kN. And for the lambda method, we obtain the QS is 439.43 kN. For the beta method, we obtain is 89.75 kN. Again, the value of QS from the alpha, beta and lambda method are close, so we do QS with the average value which obtain 301.03 kN. From that, we can obtain the QU which is 349.38 kN. And then we also can calculate the Q allowable which is 116.46 kN, which is bigger than actual load, which shows the foundation is acceptable. For the group B, the load is 200 kN with the pipe pile dimension of diameter 800 mm and the length is 18 meter with the column 2, 4 and 6. For the QQ, we obtained 85.95 kilonewton. For the QS of alpha method, we obtained 720.98 kilonewton. For the lambda method, we obtained 832.42 kilonewton. For the beta method, the QS, we obtained 271.92 kilonewton. Again, the value of QS from the alpha, beta and lambda method are close, so the QS of the average is 608.44 kilonewton. From that, we can obtain QU, which is 694.39 kilonewton, and the Q allowable for this group B is 231.46 kilonewton, which is bigger than actual load. So the foundation is acceptable. For the group C, the load is 350 kilonewton with the pipe pile dimension of the diameter 100 mm and the length is 23 meter with the column 5. For the QP is 124.30 kilonewton and the QS for alpha method is 1010.85 kilonewton. For the lambda method is 1344.74 kilonewton. For the beta method is 432.82 kilonewton. Again, the value of QS from the alpha, beta and lambda method are close, so the QS of the average is 966.14 kilonewton. From that, we can obtain the Q, which is 1100.44 kilonewton, and the Q allowable is 366.81 kilonewton, which is bigger than the actual load. So the foundation also acceptable. Thank you.
Well, good day all. I'm Reshma Gunasegaran, metric number AF180010 will be explaining about the checking of settlement for this project. We have used the basics method to check the settlement of piles. The total elastic settlement of the pile head under the working load of QW is given by SE equals to SE1 plus SE2 plus SE3. Firstly, I would like to explain the checking of settlement calculation for one group of pile, which we will repeatedly use the same method to other group of piles as well. For the first group A, the pile dimension is 600 mm diameter and also 13 meter length. So by substituting all that, before that we have performed the design calculation. From that design calculation, we have obtained the QU and QS, which will be using for the SE1 calculation. For QWP, we will use that QU and QS that we have obtained earlier, and then we'll find out the QWP and substitute it into the equation SE1, and the epsilon, which is constant range for the clay soil according to the skin resistance, where we can use from 0.5 to 0.67. I've used 0.67. So after calculating all the values, substituting all the values for SE1, I've obtained 0.5 mm, and the same goes to SE2 formula. The small QWP, which is the pile point load per unit area at pile point, we'll use the calculation for QWP over AP. When we do that, we can obtain the point load per unit area at the pile point. By substituting all the diameter and elastic modulus of soil at below the pile point, we'll eventually get the SE2 value, which is 3.11 mm of settlement. And for the SE3 value as well, we have to find out the perimeter of the pile, and substituting all that into the equation of SE3, we'll get the settlement of 0.15 mm. So for the total settlement, we have to totally up all the three settlement that we have obtained from SE1, SE2 and SE3. We'll get 3.76 mm, where according to JKR 1998, if the total settlement under the working load exceeds 12.5 mm, it is considered failed. So the total settlement is now 3.76 mm, which is less than 12.5 mm, so the settlement is okay. So the summary of design, from the summary of design, we can conclude, or we can summarize that by calculating all the settlement checking. For group A, B, C, all the settlement is considered okay, where it is under less than 12.5 mm. For group A, the settlement is 3.76 mm, and for group B, the settlement is 5.11 mm, and for the group C, the settlement is 6.34 mm. So that's all from me. Thank you.
Assalamualaikum and good afternoon. My name is Nohanis Raya binti Nosharimi, and I will present the justification for this project. The design of the pad foundation was dependent to the soil investigation report that has been done at the proposed site. In our project, we have chosen to use the deep foundation. The reason why we chose deep foundation is because it is suitable for our proposed project, which is for multi-story shop house. Another reason for this decision was because the soil type of the proposed site is clay soil, where the soil is not suitable to prevent excessive settlement. Next, the soil might undergo compression that will reduce the settlement, and piling is required to prevent it from happening. Deep foundation also necessary in this study because the bearing capacity is insufficient to support loads imposed. In designing and calculation part, we have grouped up the foundation into 3 groups based on the loading from the column. The reason why we want to group up the similar foundation into the same type is due to the economic purposes, sustainable method, and also save the construction time. We could summarize that from our calculation result that the soil properties and types obtained from the soil profile are the best suited for the deep foundation. The friction pile was used in this project. The depth is more than 3 meters times its breadth of the soil profile. Due to the soil qualities, we propose a pipe foundation and steel piles. Based on the analysis of structure, we obtained 6 loading for columns in the building to transfer load to foundation. As a conclusion, a project is being conducted by Sri Sayan Sundara Berhad to build a 4 multi-story shop house. A total of 21 columns are being grouped into 3 different groups according to its range of total load. The maximum load of the column in each particular groups, which are 100 kN, 200 kN, and 350 kN, have been chosen as the load that need to be designed. A total of 27.05 meter depth of soil with different types of soil are being analyzed. In this project, the result shows that the value of Q allowable in each group are greater than the maximum load provided. This shows that each loading in each group is bearable for the foundation support. Furthermore, the settlement for this type of soil is also being analyzed. The result in this project shows that the values for the settlement of all type of pipe foundation in each group is less than the maximum differential settlement, which is 25 mm, which makes this type of soil is passable. As for the soil improvement, a drainage systems are being suggested to this project as to reduce the water being absorbed into the soil. And that's it from our group. Thank you so much.